Welcome all of you. I am Dr. Dhondiram Tukaram Sakri, Assistant Professor, Department of Chemistry, Shivaji Arts, Commerce and Science College, Kannad, District, Aurangabad, Maharashtra. I am participated in online refresher course in Advanced Instrumentation Multidisciplinary on dated 12 सप्टेंबर 2022 to 26 September 2022 organized by UGC Human Resource Development Center, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, Maharashtra. I am opening my presentation now. My seminar presentation topic is X-ray analytical technique. X-ray analytical technique. X-ray were discovered by W.C. Roentgen in 1895 and lead to three major uses. That is, X-ray radiography is used for creating image of light objective material, relies on a relationship between density of materials and absorption of X-ray. Applications include a variety of medicinal and industrial application. Second one, X-ray fluorescence spectroscopy relies on a characteristics of secondary radiation emitted by materials when excited by a high energy X-ray source and is used primarily to determine amount of particular element in material. Third one, X-ray crystallography relies on the dual wave particle nature of X-ray to discover information about the structure of crystalline material. Uses of X-ray powder diffraction, basic materials uh, to recovered in this course. First of all, that is the radiation safety for user of X-ray diffraction. Second one, the generation of X-ray rays, the geometry of diffraction, Bragg's law, basic of X-ray crystallography, sample and specimen preparation technique. Now, Bragg's equation. Sir William Henry and William Lawrence Bragg, brother and son, his of historical perspective. Henry Bragg equation historical retrospective. Henry Bragg equation XRD analysis. XRD analysis. How to XRD attempt exclusions. What questions about answered by XRD method action. XRD analysis. How to read XRD pattern exclusion. What questions can be answered by XRD method, and a simple interpretation of one large instrument. The assumes that each crystal plane reflect radiation as a mirror and analyze the situation for cause of constructive and destructive references. The most important things in science is not so much to obtain new facts as to discover new ways of thinking about them. Now it is the Sir William Henry Bragg. It is a Nobel winner or Nobel Prize winner in 1915. Diffraction, diffractometer component and geometry. Now it is the image of, that is the diffractometer component and geometry. It is the detector. Now it is the detector disparage, and it is the whole, that is the uh, and it is the KB filter. It is scattered radiation, and it is the distogram, and it is the aperture diagram, and it is the X-ray tube. This is the X-ray tube, and this is the focus. Now in case of this theta, theta is the glazing angle, and it is the 2 theta. It is known as diffraction angle, and that is the alpha, which is the aptitude angle. It is the diffractometer beam path in, that is the theta by 2 theta mode. The Bragg equation. Now Bragg equation is equal to neta into gamma is equal to 2d sine theta, where n is an integer, lambda is the wavelength of the X-rays, d is the interplanar spacing in the specimen, and theta is the diffraction angle, that is the discussed later. The Bragg equation is the fundamental equation valid only for monochromatic X-rays, that is used to calculate the interplanar spacing used in XRD analysis. Now it is the instrument of, that is the our slanting diffractometer. This is the instrument of XRD. Now slanting diffractometer HV power supply. It is the power supply, that is the plus side. It is the plus and it is the minus. It is the plus and it is minus. Now Speculum DF3 solid state high voltage generation power supply is there. Now Sanitag diffractometer detector. It is the Bicron sanitization detector and monochromator, that is the machine of these monochromator. Now sanitizing diffractometer detector power supply, it is also the power supply image of these detector. Now the from right to left power model, another, that is the bias power supply, that is another single amplifier retemeter, that is the counter. Now example, diffraction pattern. Each peak represents the solution of Bragg's law for known radiation wavelength, that is the L is equal to 0.154 nanometer. The unique relationship between such pattern and crystal structure provide a powerful tool for the identification of the phase compositions of powder and polycrystalline materials. Now diffraction patterns are best reported using, that is the DHKL and relative intensity rather than 2Q and absolute intensity. The peak position of 2Q depends on instrumental characteristics such as wavelength. The peak position as DHKL is an intrinsic instrument independent material property. Bragg's law is used to convert observed 2Q position to DHKL. The absolute intensity, that is the number of X-rays observed in a given peak, can due to due to instrumental and experimental parameters. The relative intensity of the diffraction peak should be instrument independent. To calculate relative intensity, divided the absolute intensity of every peak by absolute intensity of the most intensive peak and then convert a percent. The most intensive peak of a phase is therefore always called the 100% peak. Peak areas are much more reliable than peak height as a measure of intensity. Now it is the example of diffraction pattern. Now it is the horizontal, that is the values of 2 theta. Now in case of y-axis, that is the intensity count. Now it is the XRD peaks. XRD peaks are observed, that is the number of XRD peaks using, that is the powder XRB software. Now this is the example of diffraction pattern. Now this is the sharp using the origin software, that is the y-axis, that is the intensity, and x-axis, that is the 2 theta, and therefore these peaks are the sharp peaks because they using the origin software. Now it is the value indexed X-ray diffraction data, that is the copper complexes of ligand L1. Now it is the peaks, that is the peak numbers. It is the values of observed, that is the 2 theta. It is the values of calculated 2 theta. It is the values of D. It is observed and it is the values of D, that is the calculated. It is the Miller indices of plants, that is HKL values, and it is the relative intensity, that is the percentage relative intensity is there. Now therefore the relative intensity is decreases in order. Now it is the example of, that is the X-ray diffraction data of copper complexes. Thank you very much. Now, I am also thank to UGC HRDC Resource Development Center, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad, Maharashtra, to providing me opportunity to joining online refresher course in advanced instrumentation, multidisciplinary. I am also thank to our course coordinator, Dr. Bhaskar R. Sate, Sir, Associate Professor, Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. I am also thankful to Dr. Rafe Sir, Assistant Director, UGC HRDC, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad, and also thankful Mustajib Khan, Director, UGC HRDC, Aurangabad, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. Thank you to all of you. Thank you very much.